awesome. But if not, you can follow those links, and that should only take a few minutes to set up, hopefully. Yeah, so if you haven't done that, go ahead and do so. And we have a few more minutes just for people to filter in. Is the recording's paused?
No, sorry, I just restarted it.
Yeah, cool. Okay, well, I think our numbers look pretty stable now, so we can go ahead and jump right in. So hi, everyone. Welcome to the GitHub workshop. I'm Jonathan. I'm a geoscience PhD student, and I'm going to be the main instructor today. Kind of said this once before, but for anyone who just filtered in, please make sure that you've signed up for a GitHub account, and also that you've installed GitHub Desktop on your computer, as we're going to be working extensively with both of those today. And just so that I know, is there anyone who hasn't, who doesn't have those set up and installed? And if so, could you do the raise hand reaction in the chat? Okay. Natalie asks, will the recording of this session be shared? And yes, it will. My understanding is all the recordings will go up on the HackMD or the ResBazAZ website after the conferences are done. Okay, as far as I can tell, everybody should be set up. So the other thing is, if you go to the HackMD for this workshop, on the Getting Started link, there's number 4, go to the workshop website. Oh, is my screen being shared right now? Let me do that real quick. There we go. Yeah, if you go follow that link, it's going to bring you to kind of all the exercises and the concepts that we're going to be doing today. So let's go ahead and head there. Hopefully everyone, also should mention, everyone should have a plain text editor open. So I'm going to be using Notepad because I have a PC, but you could also use TextEdit or Atom or VI, based on whatever computer you have. Please don't use Microsoft Word though, because Word includes various like invisible characters and things it uses for formatting, and that'll kind of mess up what we're trying to do today. And then I'm going to be checking in as we kind of walk through some of the workshops, some of the exercises in the workshop, just to make sure that everybody is being able to follow along and get everything done. So the way we're going to do that is I'm going to ask people to, if you go into the reactions tab, there's a little green check mark. Could everybody click that once now so we can make sure that everyone is able to do that? Cool. Seeing a bunch of green checks. But also a bunch of not green checks. Okay, I got some thumbs ups. That works too. Let's see, let's move the chat. Alma asks, is there an advantage to using Atom over Notepad or a plain text editor over other? Oh, yep, Mary's already responded. Yeah, for today, it shouldn't really matter too much. It's just whatever you're comfortable using. And I'm with Mary. I do like Atom. It's very customizable. Okay, well, that's a lot of green checks, so I think we'll call that good. We can clear those out, whoever's doing that as the host. Oh, and right, for a lot of these exercises, I'm going to kind of be going along and doing a demo exercise. You all are welcome to follow along with that exact demo. You can find all the files that I'll be using at this download link here. Feel free to download that and extract it. You're also welcome to try to follow along with the exercises using, your own research projects, your own code, whatever you have. That's totally fine. If there are problems that arise, it's harder for me and the helpers to help you kind of like troubleshoot and debug that, just because we might not know what's going on in your project. But yeah, you're welcome to do it either way. So with that, I think let's go ahead and jump on in. So I think a lot of people might be wondering, like, okay, I'm a scientist, I'm a researcher, I've heard of this GitHub thing, maybe have a rough idea of what it does, but like, why should I use it? Why is this a big deal? And so kind of fundamentally, GitHub's really useful because it lets you implement version control, which is to say you can save, organize, and share different versions of a research project with other people. So often in science, we'll need to document and justify the steps you take in an analysis. And if you're like me several years ago, you might, have a giant mess of code with all sorts of changes and analyses done to it. And when it comes time to like write up a publication or a paper, you're like, oh, why does this code look like this? Like, what's going on in this line here? Why did I do that again? And so having a version history is really nice because you can say, oh, like, it's documented, like, this is why I'm doing what I'm doing in this line. And this is why we started to do this analysis. Yeah, and things like that. GitHub's also very useful because it'll automatically back up your files. And so if you've been doing a research project for 4 years and then your hard drive crashes and dies, like, you're totally fine. All your work is saved. It's up on the cloud. God forbid you can burn down a building and you'll still have your research accessible. It's useful for organizing different versions of the same file. So maybe I have a script and I want to run it one way for an analysis, but then I want to change some of the parameters and run it a different way for a second analysis. And rather than going and like copy pasting and then uncopy pasting and deleting, and maybe I forget to like change something as I go between the two analyses and now my work looks wrong. Instead of having that, GitHub can let you organize the file. So you're like, here's the version for the first analysis. Here's the version for the second analysis. They don't interact. And so, really reduce the potential for confusion there. And yeah, the last reason is you can share versions with collaborators very easily. GitHub is online. It has a pretty navigable website. And so if you have other people you want to have find your code, or maybe you published an analysis and you want to make the code that went with that paper accessible, now people can find it. Yeah. And I'm going to take a quick aside here. You may have heard of Git in addition to GitHub. I might be wondering, how are those related? Are these the same thing? And so kind of the answer here is, yes, they are related, but they are not the same. So Git is a set of open source command line tools that you can use to implement version control. And so, for example, I could, Zoom's kind of in the way here. I could go down to my terminal, I could open it up, and I could, if I have these Git tools installed, I could start typing commands that would do version control. Like, oh, I made some changes, files, and I could send that via the command line. That's what Git is. By contrast, GitHub is a company that implements a desktop app that looks like this. We'll be using this a lot today. And they also implement a website for hosting code. And in general, I find it's much more user-friendly, especially just starting out with Git, or even just starting out with coding, if that's new to you. Yeah, and so in this workshop, we're gonna focus exclusively on GitHub. Don't need to worry about the command line. We're not going to be doing that today. So we're going to jump into exercises pretty quickly. But before we do that, I think it would be good if we kind of go over a few of the fundamental Git and GitHub concepts. And so these are just kind of actions that you'll see referenced again and again and again. And yeah, we'd like to know kind of the basics here. So most projects, when you're using GitHub, they're going to start out with a thing called a repository. And this is really, it's a special folder that's going to hold your project and the files associated with that project. It's where a project lives. So that's a repository, and you'll often see it called a repo for short. I'll note a repository doesn't have to just hold files. It can also have other folders within it, but it's kind of the broad encapsulating container for your project. So when we're using GitHub, your project's going to live up on the cloud, up on GitHub servers. And the version that's up on the cloud is called the remote repository. But if you want to work on a project, you're going to want to download that repository to your computer so you can start editing it, maybe work on it in a code editor. And that action of downloading it is called cloning. Once you've cloned the remote repository, now you have the repository on your computer. And the version on your computer is called the local repository. This one's not backed up on GitHub servers necessarily, but it is much, I find much easier for you to work on because you have it all right there. Okay, so you've downloaded your project, it's on your computer, and you want to make some changes to it. Maybe we're going to update an analysis, maybe we're going to add some data to some sort of database, but we're going to make changes, and eventually we'll want to save those changes, kind of when we get to a logical saving point. And so making a save in Git or GitHub is called making a commit. And this is because the state of your project when you make that commit is going to be committed to memory. It's going to be committed to the version history. You'll always be able to go back and access that version, that earlier version later on. After you make a commit, you'll have the changed files, but they're only living on your computer at this point. And kind of as we touched on, one of the great things about GitHub is it's going to back up your work. And so you'd like to get those changes back up onto the cloud. And so you're going to re-upload them. And this is called a push. And I should note, you don't need to keep cloning the repository back onto your computer. Like once it's there, it's all linked up, it's good to go. You can make a push, and then you can make some more changes and make a new commit, and then you can push those new changes to the cloud. And kind of keep doing this process where you make more commits, more save points, and keep pushing them up to the cloud to say, hey, I want this to be on my version history. I'd like to remember what was going on at this step. Yeah, so kind of putting it all together, you're going to start with your remote repository, which is going to hold a project. You're going to download or clone that repository to your computer. That's going to make a local copy called the local repository. You're going to edit your files. You're going to save those changes. That's called making a commit. And then re-upload those changes back to the cloud. That's called making a push. I've got kind of all these terms here. And I also want to note that if you go to the top page of the website under the concepts tab, there's a glossary here at the bottom that covers all the terms that we'll go over in this workshop. So yeah, if you need a refresher on any of these, hopefully it should be right here. Okay. So almost ready to start the exercise. First one we're going to do is we're going to create a new repository and put it on the cloud. But I think we should address one little assumption that was kind of in my last set of slides, which is the idea that at the very beginning of this, we already had a repository that lived on the cloud. We already had a remote repository. But a very reasonable question is like, hey, wait a second, where did that project originally come from? How did that get there? And so in most cases, you're going to need to create a repository for your project once, just one time. It's the very first time. And creating that project is called publishing it. And so, yeah, in this next exercise, we're going to create and publish a repository. I want to make a quick comment here. As we do that exercise, we'll come to a point where you have the option to make your project public or private. If you make a public project, it's visible to anyone online, whereas a private project is visible only to you and maybe some invited collaborators. In general, I would really encourage people to make repositories public, as it makes scientific results like more transparent. It makes it easier for other people to find your code. And I personally think it promotes slightly better coding, because if I think other people might try to use my work later down the line, I take like fewer shortcuts in my own coding, and I generally do a better job. And it might take a little more time up front, but it definitely saves me a lot of time in the long run. That said, everybody's project is different. You might not like the idea of other people being able to see your work. So like, absolutely go with whatever privacy permission is best for you. Okay.
Jonathan, can I ask you something?
Yes.
Yeah.
Please.
I typed it on the chat, but I can just say it. I'm wondering if we can make our private repositories public later on.
Yeah. That's a great
like some of my
question.
work is associated with like things that are gonna be an article, and I cannot make it public before I publish, right?
Right. Yep. And that's absolutely, you can absolutely do that. You can always take a private repository and make it public later on after you publish. Yeah, that definitely works. I will say it's hard to go the other way. You can take a public repository and you can make it private, but all the parts of that repository that were public initially, they're going to stay public forever. Although your new changes might be hidden. Yeah, but yeah, you can always start private and go to public later. That's fine. Okay, and so with this, I think we'll go ahead and jump into the first exercise. So we're going to go ahead and we're going to create a repository. So the way we're going to do this, and once again, Zoom's kind of in the way. Move this real quick. Okay, so go ahead and open up GitHub Desktop. And you should see that kind of in the top left, there will be a File tab. You click the File tab, very first option is going to be to make a new repository. So go ahead and click that. And it's going to pop up this like create new repository window. We've got a couple different fields to fill out here. The name, so the name of your project. Ideally best to use something descriptive so you remember what this project is later on. You can put a little description in to, again, just kind of remind yourself what this project is for, maybe what this code does. Local path, that's going to be where on your computer it's created. And then there will be a few more options down here that we'll touch on in a second. So I know we probably have people with all sorts of different coding backgrounds or different scientific research backgrounds. And so I wanted to have a demo that hopefully kind of everyone would be able to follow along the basic idea of. And so I'm going to be doing kind of a mock-up of a research project to find a recipe for salsa verde, as I figure I think most of us understand kind of how recipes work and how you could sort of build mock-up code off of that. So yeah, feel free to follow along with this demo or with your own work. But yeah, so I'm going to create this salsa demo repository. And the description is, this is my project. Finding best recipe for salsa verde. All right. I'm going to build it into the kind of GitHub workshop folder on my computer. And I'm going to initialize it with a README. I'd go ahead and recommend that everybody click this box to make the README. And it's just going to it's going to create a file that basically holds the name and the description of your project. You also see these git ignore and license options. Just leave those as none for now, although we will come back to them a little later. So once this is all set up the way you like it, go ahead and hit the create repository button. Desktop's going to think for a little bit. And okay, it did it. It's done. We created our repository. Now let's go ahead. We can go ahead and look at this in our computer. So I'm going to open up like my file browser here. And GitHub has created this salsa demo folder, which is my salsa demo repository. And if I go in here, I can see that there are there's kind of three things in this repository. There's that README file, and then there's a file called git attributes and .git. For the most part, you don't really need to worry about the .git and the .git attributes file and folder. And these are things that GitHub is going to use to keep track of your project. It's what GitHub is using to like look at the different versions and the different save points in your project, but it's usually not something you need to edit. I'll also comment on some computers, you might not even see the .git folder at all. And this because it's often a hidden folder. A lot of computers just know that if they see a folder called .git, it's being used for version control, and it's not really something you need to be editing. So they'll often hide it. So don't worry if you don't see that one. But you should see the README file. And let's go ahead and open that up real quick and just see what's in there. I'm going to open it up with Notepad, which is my text editor. And you see, yeah, as before, this README file is mostly, it's listing the name of my project, also that description I typed in. And I could go through and add more details to this later if I want. But for now, it's just a nice reminder of, what is this project? Let's see something in the chat. Don't ever delete the git or the .git attributes folder if you do see them, because they're quite important indeed. And at least on your computer, if you delete the .git folder, you won't be able to track changes anymore until you re-clone, that is to say, re-download the repository from the server. Okay. Let me just make sure. Yeah. So we've created this repository, and now we want to do that publishing step so that the repository is up on the cloud. So go ahead and open GitHub Desktop again. And the first thing we want to look at is kind of this leftmost tab. This is the current repository tab. If you just created a new repository, that repository should be the current one. But if it's not, you can click this tab and you can see a list of all the different repositories on your computer. So if you are not on the demo or whatever project you're on, select it from this list so that it is the current one. Then if you look at the rightmost tab, you should see this option to publish the repository. So we're going to go ahead and click on that. And it'll pop up with this publishing box. Again, it'll show us the name and the description of our project. And then this is where we'll have the option to make our code public or private, at least initially. I'm going to go ahead and make this demo public, but you should do whatever is best for your own work. And once that's done, I'm going to click on the Publish Repository button. So now GitHub's thinking, it's communicating with the GitHub's cloud servers. Okay, and it's done. So now that we've done this, we can go to GitHub's website and we can look at the remote repository, and we should see that our files and this project are actually, they're alive and they're online. So let's go ahead and do that. Have everyone go ahead and go to GitHub. So that's github.com. And when you do that, you should see a page that's something like this, or you might have to log into your account, but then you'll get to this page. And when you do so, you'll have a bunch of repositories listed here kind of in the left-hand column. So for myself, we can see, there's the salsa demo. So you can go ahead and click on that click on that repository, and it will take you to the page for that repository. It's possible some of you might get a page that looks a bit more like this, which is kind of your user profile. If that's the case, you've got the repositories tab kind of here in the top middle of the screen. If you click on that, see a list of all your repositories, find the demo, click on it, and again, we'll be on this repository page. So on this page, there's all sorts of buttons, all sorts of tabs. There's tons of different options and things you can do to a project here. Most of them are beyond the scope of this workshop, but I would certainly encourage you to come back and investigate some things later. For now, we're going to kind of focus just on this middle tab here, or this middle panel. And what this is doing is showing us all the files that are in our project, or in this repository. So here we can see the Git attributes and that README markdown file. And so that's great. We've created a project. It's backed up online. Awesome. I think at this point, why don't you all give me a green thumbs up if you've managed to create and publish a repository. And if you're having any troubles with anything, please just drop a question in the chat.
Also, I'm just gonna take this moment to say that if anybody needs like a lot of help, I can invite them to a breakout room and help them through it. That's also a possibility. So if you're completely lost, let me know.
Okay, seeing some green check marks. Again, if you're having any troubles, feel free to put up like the red X or the raise hand. Otherwise, I'm going to keep going in just a minute. Okay. Looks like people are doing pretty good, so we'll keep moving on. So we've gone ahead and, oops, wait for it, there it is. We've gone ahead and we've created this repository. But at this point, this is not a particularly useful research project because there is nothing in it apart from a quick description. So it's time to start adding files and making edits and doing some research in this project. So the first thing we're going to need to do is probably just straight add some files. So for my salsa demo, if you go to those demo files that I downloaded, that you could have downloaded, you'll see there's a file called ingredients.txt. And if I open that up, you'll see that this is just, it's a list of salsa ingredients. Pretty simple. And this is going to be the first thing that we add into this project. So I'm going to go and I'm going to copy this file into my salsa demo repository. Like so. So now this repository is holding our new file. And if you go to GitHub desktop, you can see it actually lists that new file here under the changes tab. And it's got a little green plus on the side of it, and that's indicating that this is a new file. And here in the center pane, you can see the actual contents of that file. There's the ingredients list. Now, at this point in time, GitHub is not actually keeping track of this file. It's saying, hey, this is in the repository, it's a new change, but we haven't actually saved anything about the file yet. If we want to save that file, we need to make a commit. So to make a commit, you're going to go down to this left-hand box here, bottom left, and that's the commit box. And this has three components to it. The first field here is a description of your commit. Usually this is going to be where you say like what changes you've made to the project. You can optionally put in a longer description here of whatever changes you made, and then you have the actual commit button itself. So in my case, I've added ingredients. So I'm going to say I added ingredients to I think that's pretty self-explanatory, so I'm not going to put a longer description here. And instead, I'm just going to go ahead and click the commit to main button. And so now that I do this, you'll see that that ingredients.txt has disappeared from the changes tab. And that's because the repository, it's tracking that file now. It has, the most recent save point includes that ingredients.txt file. And so there haven't been any necessarily new changes. Now, let's go back to the remote repository. And you might have to refresh the page here. But when we do that, we see, oh, where is ingredients.txt? It's not there. Why can't I see it? And so the reason here is that we haven't pushed that commit back up to the remote yet. So we need to save those changes. So go back to GitHub desktop, and you see that the rightmost tab should, instead of saying something like publish or fetch, it should now say push origin. It's got a little 1 here to signify that there's one commit that is stored on our computer that hasn't been pushed yet. So if you click this push button, it's going to handle the push for you. It's thinking, okay, it's done. Now if we go back to the remote and refresh, we see, now that ingredients.txt file is there. You can even click on it and open it up and say, yep, those are the contents of that file. And so cool, that work has been backed up and it's saved. Yeah, so with that, committing is kind of, one of the most essential steps that we're gonna be doing. And so I think it would be really good for everyone to just practice doing it a few times. So I think it would be good if everyone could go ahead and make at least 2 more commits to whatever, practice repository they're using, and then give a kind of green check mark when you're done. And you can make plenty more than that, but try to do at least 2 more. So for my own, I'm going to go and I'm going to add in kind of some research notes, and I'm going to add in some instructions from actually making the salsa. So I'm going to copy those files into my repository like so. And I should note, you can change multiple files. You can add multiple files at once. So when I go into GitHub desktop, we'll see, here's both my instructions and the research notes. Instructions are pretty simple. It's, boil the veggies, drain them, and blend them with cilantro and salt. Research notes, we need to test this recipe. We haven't done anything yet. So I'm going to make a new commit. I added instructions, notes. I'm going to click the commit button. And I'm going to make another commit. Now that I have those kind of instructions together, I'm going to go through and I'm going to write a little bit of pseudocode. This is kind of a mock-up of a MATLAB script that would, make salsa verde. So I'm going to copy this salsaverde.m, code script into here. If I go into GitHub, again, there's the new file. It's got the little green plus beside it. And so I'm going to be added code. I'm going to commit that. Then I'm going to push these changes to the remote. It's thinking, okay, and it's done. And again, I can go back to the remote repository. Might need to refresh the page. And you can see there are all the new files that I've committed. Okay. If people are doing well, give me a check mark. And if anybody's having difficulties, yeah, just raise a hand. Okay. I don't see any hands. I see a bunch of green checks. So looks like people are doing good. Okay, so we've made a commit. We've also pushed the new file to the remote repository. We've done some practice. So now we're going to move on to a slightly more complex topic. So part of this stems from GitHub is very much set up to organize small text files or code files, but generally things that aren't large databases. And so consequently, if you try to commit a file that is larger than 100 megabytes, it's gonna create a bunch of errors. It's really not gonna like it. But for the purposes of scientific research, we often do need large databases or large binary files, and we often want to keep them in the same folder as the rest of the project. And so kind of the way to get around this in GitHub for Git and GitHub is by creating a file that's called a git ignore. And essentially, this is a text file that you're going to put in the top level of your repository. And it's just going to list off files that Git should always ignore and never try to commit. And so, yeah, some common files that you might want to ignore, like I said, are databases, .nc, .dat, or large CSV files. You might also want to ignore just kind of automatically generated files that don't have anything to do with the project. So if you use a Mac, you might have seen those .dsstore files, which really just includes information for your Mac to do file browsing. It doesn't actually relate to the project in any way. Or if you use MATLAB, you may have seen those kind of autosave files that generate. If you're using R or Python, there are kind of project and cache files that don't actually do any part of the analysis. You might want to ignore those too. Right. So to make a git ignore, we're going to go in a text editor, kind of open up a blank file, and you can really start listing off files here. If you only have one specific file that you want to ignore, you can type its name in directly. So, my database file.nc. If I saved this as a git ignore, Git will never try to track that file. You might have a lot of different files of a particular format. So maybe I want to ignore all files that end in .data. To do this, put 2 stars followed by the file extension. So **.data or **.asv would ignore any file that has those particular characteristics. Another common one that you'll see is people making a folder that holds all of their data, a database folder, and then maybe your scripts in your code are in a different folder. So you can ignore a folder by writing the folder name. So like my data folder, and then putting a slash mark after it. And so kind of putting it all together. Oh, I should also note you can do a comment in a git ignore by doing a hashtag, and then anything following the hashtag on that line will be a comment. So you can kind of remind yourself what's going on. Yeah, and I've put an example here kind of what a real git ignore might look like. And again, to make a git ignore, you save the file with the name .gitignore and you put it in the top level of the repository. So now let's go ahead and try that out. So if we go into the kind of demo files again, oops. One second. Yeah, we'll see that there are 2 kind of database files I've put in here. One of them is called Salsa Database, and the other one is called Chile Data. And so let's take those 2 databases, and I'm going to move them into the repository. And okay, there they are. And you can see from the file size that both of these are larger than 100 megabytes. And so GitHub will get unhappy if I try to track them. If I go and open up GitHub Desktop, you can see that both of those files are listed here. And that's not really good. I don't want them to list here because I don't want to accidentally commit them. You can see kind of in the center pane here, it's saying the diff is too large to be displayed. That's because the file is greater than 100 megabytes. It's not really happy. Okay. Now we could go through, we could manually uncheck these, and then we'd actually be okay again, because if we uncheck the files, then Git won't try to commit them. But that would be really tedious to do if we needed to do it, excuse me, for every commit as we go. So yeah, we're going to make a git ignore. I'm going to open up Notepad. I have these two files. I'm going to remind myself that these are large databases. So ignore large databases. And then I'm going to list the name of both files in here. So chili data.nc, salsa database.mat. Okay, so now I'm going to save this as .git ignore. I don't want it to be a text file, so I'm just going to save it like as all files. This is the name of the file. I'm going to put it in the top level of the salsa repository. Okay. Let's go check that that worked. Yep. There's my git ignore. And when I do that, you'll see that the Chile database and the salsa database files have disappeared from the GitHub kind of changes pane. So that's great. They're being ignored. You can also see that the git ignore itself is there, and we should add that to the save so that we continue to ignore these databases in the future. So I'm going to make a commit where I added git ignore. I'm going to commit that. And finally, we're going to push it. And now, move Zoom again. Now, if we go to the online repository, we'll see that, yep, there's that git ignore, but importantly, those large databases, they're not up here. That's good. So let's see, why don't people go ahead and try to make git ignore of your own and give me a green check when you're good, and any hands if you're having troubles. Allison asked, what type of file did I save it as? And I'm sorry, Anthony, I did not save it as a .text. You save it as a .git ignore. It doesn't have a name. It's only a file extension. It's only .git ignore. I'll drop that in the chat too. If you have an editor, most editors will, if it's a text file, they might automatically append .text to the end, but usually there will also be an option to save it as like all files or something. That's what I did here with this one. You save as, if I saved it like this, with .gitignore.txt, that wouldn't work because it would have a .text extension. So yeah, change it to all files, and then it only saves as .gitignore. Oh yeah, John has a good point. If you try to save a file name, you can put it directly in quotes, and it'll usually save exactly as that and not append anything onto it. Let's see. So how are people doing? Anyone having any issues with this? Hopefully people have been able to save it with the right name. Okay. Seeing some check marks. Not seeing too many hands. So why don't we go ahead and move on. Oh, something in the chat there. So Amma asks, just create the git ignore and it will automatically ignore that file. If you create the git ignore, it'll ignore any files that are listed in the git ignore file itself. So like for mine here, here's the git ignore file. Here are the files that are listed in it. So these are the files that are being ignored. We don't actually want to ignore the git ignore file itself, because that has important information about which files to ignore. So you do want to commit the .git ignore file to your repository. James says, I'm using a Mac and will not let me save a file with the dot at the beginning. It's reserved for system. I might move this one to the helpers. I don't have a Mac and I'm not as familiar with this problem. Do any of you know how to address that? Let's see. How are we doing on time? It's 10:45. Okay, so Chin says, if you are having trouble with text edit, starting a file with a dot, try using the command touch or open textedit.gitignore. I'm not an expert on that, so I will defer to their wisdom there. Okay, I think with that, let's move on through one more exercise, and then we'll do a 10-minute break at about 11 and go into the second part of the session. Okay, so right, so we've made a number of commits now. We've added a git ignore. We just did some practice making commits and pushes. And so now we can start to get into some of the really powerful aspects of GitHub. And that is that GitHub is always tracking all the changes to your files, and it's making a version history to everything as you go. So let's go ahead and start to make like another commit. I'm going to open up my ingredients file. I'm going to add like a little more information about how to prepare each of the ingredients. So I'm going to open up ingredients.txt. And let's see. Remember what I actually put here. I'm just going to copy this in direct. I'm going to copy this edited file into my ingredients file and see, okay, the tomatillos should be peeled and washed. The jalapenos should have the seeds and stems removed. Cilantro should be chopped. Garlic cloves should be peeled. As we do this, we can go into GitHub and oops, have to save it. Let's save those changes. Okay. And oh, my bad. I put that in the wrong folder. So let me start that over again. I'm going to go into the salsa repository. Get the ingredients. Okay, so we're going to do washed. These should have the seeds and stems removed. These should be peeled. And this should be, I'm going to save those changes. You can see, okay, there's that ingredients file. And if you look in the middle pane, it'll actually show you all of the changes that have been made. The lines that are in red are showing where a line has been removed, and the lines that are in green is showing where a line's been replaced. So for example, the 8 tomatillos line has been removed, and it's been replaced with the 8 tomatillos, washed line. And this can be really nice if you have a large script and you make a number of changes to it, as you can scroll through and see, specifically what parameters did I change? Did I give the input arguments to my code correctly, etc. Also, any lines that haven't changed will just be kept in white. And if it's a very long, say a code script, where you made a small change up at the top, a small change down at the bottom, the desktop app will kind of collapse all the unchanged lines so that you can see specifically what you have altered. I see some stuff in the chat here. Great. Right, so we've examined the changes. Yeah, we already did a little more practice committing, but let's go ahead and add 1 or 2 more on here. So here I added more information to the ingredients. Everyone can go ahead and add on like another 1 or 2 commits here, because again, it's very good practice. Let's see. For my demo, I'm also going to change the time that the vegetables are boiled from 5 minutes to 10 minutes. So I'm going to save the change to the instructions. And I'm also going to update that in the code. So boil the veggies for 10 minutes. We go, you can see there's my 2 files. You can see that 5 has been changed to 10. And again, 5 has been changed to 10. So I'm going to make a new commit. I increase the boiling time. And maybe here I want to put in a description. I say why I did this. The tomatillos were still firm. And if I'm writing up this salsa recipe as a report later, I can come back and be like, why'd I change the boiling time? Oh, that's right. Yeah, now I know why. So we can make another commit. Okay. And with that, we've made a number of commits to the project. Let's click this history panel. And you can actually see all the different things that we've done over time. And you can see the changes that happened in each one of these commits too. So for example, if I go to the added more information to ingredients history commit, I can see this is what changed. Here's the ingredients.txt file, and here are the changes that were made to it. Or I can look back to when I increased the boiling time, and I can see that, oh, okay, I changed the code here. I changed the instructions, and this is the reason why I made that change. And so this can be very useful, yeah, for looking back on your progress and your history and knowing why you've done things. Yeah, so we've examined the version history. Oh, right, okay. And the last thing we should do is note that you can also find this version history on the remote repository. Let's go back to GitHub desktop and let's make sure that we push these commits that we've made, because otherwise they'll just be on our computer and we can't share them across devices and they won't be backed up and all. So now that we've pushed that, we can go back to the repository, and you'll see in this kind of right-hand corner there's a little clock that lists how many commits have been made total. And so you can click that clock and you'll see a screen like this that lists all the commits you've made over time, along with when you made them. And if you want, you can browse the code at those different commits by going to these kind of angle brackets. So if we go to that, we can actually see what the project used to look like at this old commit. So let's see. What did I just do in this one? This one, I added more information to ingredients. So if I look in the ingredients.txt file, you'll see that the ingredients have kind of that more information. But this is the commit before I increased the boiling time. So you see, if I go and look in the instructions, I can see that, oh, on this older commit, this is what the code looked like before I increased the boiling time from 5 minutes to 10 minutes. So if you ever need to go back in your code and try to recover an old version, it's very easy to browse back to that old code and recover it here. Yeah, okay, so that's kind of that exercise. Why not, yeah, I'd say if everyone wants to make a few more commits, see if you can, yeah, take a look at the version history in GitHub desktop, and then try to browse the code for an older commit on the online website Give me a thumbs up when you're good. Or if anyone's having any issues, yeah, just raise a red flag or a hand or anything. And I think this would actually, it's almost 11. We're kind of at the end of this exercise. So let's do a 10-minute break here. We'll come back at 11:05. And if anyone's still working on this particular exercise, go for it. I'll still be sticking around. If you have any questions or any issues, just drop them into the chat. And yeah, we'll reconvene in 10.
Okay, great. I had a quick question. I'm a little bit behind, so I didn't want to slow the train down. So can I share my screen with you while we're on break?
Yeah. Let's see, I'm not the host. So whoever is the host, if you want to add screen sharing privileges, I'll stop my share.
So yeah, I've only ever actually used GitHub through RStudio, so it's a little different through the just general desktop version.
Yeah.
So I want to see, I'm trying to just edit my files and I missed that part. So I've downloaded your repository.
Okay.
The demos, and then I made changes, and then after I make the change, then I'm committing, but then it's not seeing any changes.
Is the issue that like online you're not seeing the changes?
No, I'm not seeing it in my desktop version of GitHub.
Has it been saved? Because sometimes like I'll have a file, depending on the editor, it might save the changes to the editor, but not actually save the changes to the file. Like I know Atom will sometimes do that. Oh, I think you can share your screen now. Yeah. Is that the ingredients that's in the like zip downloads file, or is it the ingredients that's actually in the demo repository? I heard a dog barking. Oh, no. Okay.
Sorry, my bad. Yeah, my dog was barking, and so I muted myself.
Yeah, I gotcha.
Okay, so I downloaded the demo, and then I unzipped it, and then I created the repository from local files. So I went here, add new local repository, and then I pushed it to GitHub.
Cool. Can you open like the demo repository file on your computer, like in a browser?
Yeah.
So that's demo files, but I don't think that's your demo repository, because your demo repository is called demo. Yeah, or maybe it's DEMP.
Well,
I'm not sure.
I downloaded it. It was here, demo files.
Yeah, but the download is not. The download was just literally a bunch of files. It's not a repository. So when you created your repository, it's somewhere on your computer. If you open up GitHub Desktop, I think it'll tell you in the top left where that is. Yeah, just hover there a second. Yeah, so go to the demo file /DEMP.
DMP, I was in a hurry.
Yeah, all good.
Files slash D.
Yeah, so
here.
DMP is the repository. That's
Okay,
what's in there right now.
So then I can add it. I can add things to this, and then it will
Yeah,
show
you
up
can
there.
put things into that, and then edit them
great.
once they're in there. Yeah.
Great, that makes sense. I appreciate it. Thank you.
Yeah, no problem. Yeah, anytime.
Should I pause the recording? Oh, yeah, okay. I'll do it until we're back on. Oh, you're muted. Sorry, I cannot hear you.
I was gonna say it might be a bit late now because I think we'll jump back in soon. But yeah, sure. If there's 2 or 3 more minutes,
Okay.
yeah, we can cut that out.
All right.
Let's see. I don't see many thumbs, so give it a second more. Oh, okay. There are some. Oh, okay, there's a lot. Cool. Cool. Okay. With that, why don't we keep moving on? I should have my screen back up again. Yeah. Okay, so at this point, we've seen how to make commits, how to push those commits, and how to look back at that version history of changes that we've made to a project. Another really useful aspect of GitHub is that you can use it to undo changes that were, bad. And this is called reverting a commit, because you're reverting back to an earlier save point. But kind of in this next exercise, we're going to go through and we're going to make a bad commit and we're going to get rid of it. So if I go into my, one second, there we go. If I go into my salsa repository, let's pull in the ingredients list. Let's say I've decided that I want to experiment with the amount of salt that I put into this recipe. And something goes horribly awry. And we ended up adding in, 3 gallons of salt. Maybe it was supposed to be three teaspoons, 3 tablespoons. We go into the changes tab. We see that really bad commit. Let's go ahead and make that commit. So I'm going to add way too much salt. We commit that to main. Now I go through and I make this recipe and I realize, oh my God, this is terrible. What on earth is going on here? Well, we can go into the history tab and we can see that most recent commit where we added way too much. And if you right click on that commit, you'll have some options here. The very first one is going to be this revert changes in commit. So if we click that, actually, before I click that, let's go ahead and just look at the file real quick. Sorry, I've got a lot of git ignore things open right now. Let's close those. All right, so we can look at ingredients.txt and we see, there's what I just typed and saved. There's 3 gallons of salt. Now, if we go and we right click and we revert the changes in this commit, it's going to think a moment. And then on the history, we'll see that it's undone those changes. And if you look kind of in the history of what's happened, you can see that the 3 gallons of salt line has been turned back to half a teaspoon of salt. We can come back into the repository here. We open up those ingredients.txt. You'll see that the line has been turned back to normal. It's back to a half a teaspoon of salt without me actually needing to go and edit any file at all. And so that can be really useful, especially if you're doing a research project, maybe you try out some new experimental feature, it doesn't go well, or you make some changes to the code that breaks everything. Now you have a way to unwind those changes and get back to a previous working state. So I'm going to go ahead and push those online. It's going to think. Okay. And once again, we can go to the remote repository. We can look at all the commits we've made. Oops. Let's refresh this real quick. And we can see, yeah, there's the point where I added too much, but now the backed up version is back to normal and it has proper amount of salt. Let's see. So we reverted the commit. Why don't we have everyone go ahead and try to do make a bad commit and revert it right now, and give me a green thumbs up when you're ready to go. Sorry, not a green thumbs up. Give me a green check or a thumbs up. Maybe you're into gardening. Okay. Let's see, a few people are done. All right, we got more coming in now. Nice. So sometimes maybe you have a couple commits that you made. Maybe you changed your code, over a series of save points, and it broke somewhere in there, but you're not really sure where it broke. In this case, reverting might not be quite as useful because you don't know, which changes you need to revert. Or maybe you made some good changes as well, and you don't want to undo those. So one thing you can do GitHub Online here is you can go back to your old version of the code, which we looked at before, but you can also download the old version. You don't just have to look at the files. So if I want to go back to this commit before I did anything with salt, just to remember, here we are in the repository. We have this clock with the 9 commits. Click on that, and that brings us to our history. You can go to a specific commit, hit the angle brackets over here to browse that point in the history. We looked at this before, but now I want to point out this green download code button. So, you can click that. You can open the old code with GitHub Desktop, or you can download the zip directly. For practical purposes, I often find I prefer to download the zip directly. That's just what often works well with my workflow, is because then I can kind of examine that one separately without having to worry about the changes being tracked or anything like that. But you should do whatever works best for you. But yeah, it's a nice way you can download and save the old zip of your code. If you have a deadline and need to have an old working version suddenly working for you again. Let's see. Yeah, again, we'll have everyone do that real quick, and then we'll move on into kind of the next section here on branches. Yeah, just give me a thumbs up when you're ready to go. So Amma asks, shouldn't all that be on our computer since we pushed it from our own computer? Sort of. What Git is doing when it stores the different save points is it's in part tracking all the different changes that have been made. They're called diffs. It's like the difference between the file at point A and the file at point B. While you could go through the stuff on your own computer and try to reconstruct it from that .git file folder, it would be a pain. And so in general, I would recommend just going online. I think it tends to be easier that way.
So do you recommend, and you might have mentioned this, so you're downloading the zip, and then are you creating a new repository with downloaded zip, or do you just take the files out that you need fixed?
If you download the zip, it's just a folder. It's just a folder with some files on it. Nothing's being tracked.
Okay, so you can just change the files out that you need. And
yeah, you could do that.
Okay,
yeah.
Cool.
Again, this is often for a quick fix. I feel when this comes up, you change your files and suddenly you need to do a figure for a grant or something, and you just need a quick. I need to be able to run it once like it used to be. Yeah, and so that's why it would be downloading. The more long-term solution is to debug your code, or maybe we're going to talk about branches in a bit, but you could do a thing called making different branches where you have an old working version that just lives separately down here, and a different version that you try out new features on that's somewhere else. And yeah, we're about to move into that. Eric says, it sounds like there are many options to revert or change things, and that some of this comes down to preferences. And Sean says you can do it. It's just that you're in a detached state, and it gets into some deep confusion of where you are. Yeah, so I think both of you are very right there. Eric, yes, there are different ways. In some part, you could even do some of the commit reverting online, but I would in general avoid downloading the old zip. I think reverting is the better way to do it, because like Chun said, the whole The whole point of version control is that everything is documented. It's part of this repository and you can see its history. And if you suddenly have just like a random folder with a bunch of files in it, that's not part of a repository anymore. You don't know why it looks that way. You don't know where it is in the version history. It's just a floating bunch of files. Who knows what's going on there? And I think as we'll just move into this next section on branches now, but I think that will make some of this a little more intuitive. So yeah, let's go ahead and step into branches. So yeah, I'm gonna just kind of go over the concept of branches here, and then we'll jump into some exercises. So far, kind of all of our version histories have been very sequential. Each commit is following the next, and it's just in a straight line. So I've got my little diagram here where we have commit 2, commit 3. If we go to GitHub and we look at my history here, like all these are just like in a straight line. One happens after the other, and there's no deviation from it. But a lot of times it can be useful to have different versions of your code being managed simultaneously. So for example, we were talking about maybe you wanted to test out new features and something went wrong. Well, a lot of times it can be useful to have like one version of your code that's it's the stable version and it works. And then you'd like to take that stable version and you'd like to build off of it and you'd like to try out some new features, but you want to keep that one separate from the stable version in case you do want just the code that that works, in case you want that later. Another situation this comes up with research is, maybe you have some scripts that are built up for an analysis and you want to adapt them to a different analysis. You want to change some parameters, you want to tweak this, or like maybe you want to change the script from, publication A to publication B, and you need to change some values in there. In this case, we might want to start having multiple different versions that aren't in a sequential line anymore. And again, kind of here's my diagram of how that might look. You might want to be able to, kind of have this common version history that then splits off and goes different ways. And each of those different splits are managed independently. And so in Git, these concurrent versions are called branches. They're all derived from a common point, but each branch is going to have a unique history after the split point. So yeah, if this was our initial branch, maybe up to commit 3, we kind of built out the basis of our script. And then we made this commit set parameters, which was for a certain publication. Whereas, for this branch that's making a new feature, we kind of again, we have the common history up to commit 3, but then it started doing its own new thing as we test out, this new code. But once you're able to start making commits, you can start switching between them and working on them independently as you need. So in this next exercise, we're going to go ahead and we're going to make some different branches. So we go back to GitHub Desktop. So far, we've talked about the left tab. That's the tab that tells you about different repositories. We've used this right tab. This is the tab that communicates with the remote repository, but we haven't done this middle one yet. So this middle tab is the branch tab. And right now it's listing our current branch, which by default is going to be the main branch. Although in older versions of GitHub, you might also see master branch being the default. If you click this, you'll see there's an option here to create a new branch. So let's go ahead and do that. So I'm going to create kind of, one of these concurrent versions of my salsa repository. And I'm going to sort of do it in the context of trying out a new feature. The idea I'm going to do here is what happens if we roast the tomatillos before we add them to the salsa? So I'm going to call this branch roasted. And it's usually good to give your branches informative names. If you have a big project, you can end up with many different branches, and it's nice to be able to tell them all apart. So this is roasted. So put the name in, you can create the branch, and it's done. Now you'll see here that the rightmost tab, it has that publish option again. So whoever my host is, something's going on with breakout rooms.
I just opened the breakout rooms because I'm gonna try to help somebody.
Okay, cool.
You can all stay here.
Okay.
It's just for me and
cool.
Yeah. All right.
Great, thank you. Right, so we've made our new roasted branch and we have this option to publish again. That's because when we did our original publishing the repository, what we were really doing was we were publishing that main branch. And so each new branch that you make, you'll need to publish that separately. So we can go ahead and click this. And we have now published a new branch onto GitHub. Just give me a quick second here. Yeah, so let's go ahead and make some changes to this new branch. So right now, if we look at GitHub, we'll see that I'm on the roasted branch. So let's make some changes to that roasted branch. I'm going to, in my research notes, I'm going to put a little to do, which says I need to test roasting the tomatillos. I'm going to save that. I'm going to open up the instructions and I'm going to say roast the tomatillos 100 for 15 minutes. And let's go ahead and commit that now. I'm going to say I added instructions roasting tomatillos. And I'm going to commit that. Now, if you look down at the commit button, you'll see that it says specifically commit to roasted. And so this is important to note because we are making this change on this branch, but not on the main branch. So we can commit. And we can now look at the different version histories. You see on this roasted branch, so here's all the familiar commit history up to the changing back of way too much salt. And you can see that here's now this new commit that we've made to this new branch. We see these changes where we roasted the tomatillos. But we can also switch branches. So we can click that tab and we'll see a list of all the branches in our project. If we click the main branch, we can go back to main and we can see in the version history for main, it just stops at the adding salt step. It doesn't have that step about adding tomatillos. So we have these two branches going separately. Main can continue to develop separately of the roasted branch. So if we go into main right now, you see we're on the main branch. If we go back into the repository, we can look at the instructions. And since we're on the main branch, that step about roasting is just gone. Let's make a different change on the main branch. Let's say I want this to be a little spicier. So I'm going to increase the number of tomatillos jalapenos up to 4. So we go back to GitHub desktop. We're on the main branch. So doubled the peppers. I'm going to make that commit. So now, again, on the main branch, the history goes up to the salt, and then it doubles the peppers, but it doesn't include anything about roasting. If we switch over to the roasted branch, you can see the commits we made here don't have anything about doubling the peppers, but it does have the roasting instructions. And we can push those changes to GitHub desktop. So I'd say, why don't we have everyone? Oh yeah, okay. Let's look at the remote repository real quick, and then we'll have everyone do the demo. Yeah, we go to the remote repository. here's the salsa demo. You can see this little like fork icon here now lists that we have 2 branches. And the current branch is listed, here in this little tab. Now that I've pushed the roasted branch over, I can switch over to the roasted one here. And you can see here's the new commits that I added to the roasting branch. Like for the instructions.txt, I added instructions for roasting. There's the new step. But if I go back to the main branch, that step's not here because that's a separate branch. Cool. So I would say, why don't everyone make 1 or 2 branches for your project? Try to put a commit on each branch separately, and then, yeah, compare them. And give me a thumbs up when you're done. And branches definitely get confusing, I think. So please ask if there are any questions.
So if, let's say you're working on a branch and you commit and then you push to GitHub, and then you want to go back to working on the main branch. Yep. Should you pull the main branch again before you start working? Because now the saved files are different than what you would with the previous main branch, if that makes sense. So it's not, so like just the file itself is different on your local machine.
Yeah, the file itself is different on your local machine. But since you have the branches here, like in GitHub Desktop, you could flip over to main.
Yeah.
And that's going to change the files back to their original state as they were on the main branch. You won't have to touch any of the files. It'll all do that automatically. That's part of what makes a repository different from a folder. Is a repository allows Git to like go in and change and save all your files anytime you switch things without you needing to touch it.
That's awesome.
Yeah, it's very nice. Yeah, and so if you're working on research project A, you can have your code, set up on the main branch, and then you're like, all right, research project B, where I want like it to do a slightly different thing. You change it and boom, your code is set up to run in the way for research project B, and you don't have to touch anything else on your computer.
I have a question as well. If you are wanting to make changes to the main one and also have those same changes in the branch, like if you realize you made a mistake and the overlapping code, do you have to go back now and do that twice in the main and then also in the branch?
So you're touching on the very next thing we're going to get to, which is merging branches. I think the answer is both yes and no. It's kind of a matter of preference. You could go through and change it on both branches because you're right. If you like fix it on the main branch, it won't be fixed on the roasted branch. However, as we're about to see, there's a tool called merging where you say like, hey, look at what I changed here. Like put those changes on this other branch. And then it'll do it automatically without you again needing to go in and like, type into the files directly. Let's see, how are people doing? Get some thumbs up or checks or hands. Or just hold up, we're not done yet. Cool. Well, I'm seeing some thumbs up. I'm not seeing any other indications of trouble. So let's keep moving on. We're doing on time. Yeah, we're pretty good. Yeah, so as we were kind of just saying there, great segue, thanks. There's this tool called merging branches. And this can be useful, as was just said, maybe you found a bug and you realize it's on both branches and you want to like put the bug fix onto both of them. But another time that merging branches can be useful is like, say that you're developing a new feature and you actually finished developing the feature and you're ready to put it back with the original code because you know that this new feature works and it doesn't have any bugs and everything's set to go. Right, so that process is known as merging, and it, oops, sorry, my mouse jumped. And it's going to combine kind of two branches into, it's going to combine the version history of them. So, you know, kind of in my demo figure here, we had this main black branch where we, you know, had some parameters set up. We had this feature development branch in red, and we want to like merge them together. And when we do that merge, it's going to move all the points of those two independent version histories together. So you can still see like what was done in every step. It's just going to consolidate them into one single branch. So in most cases, not most, in many cases, merging can be pretty straightforward. As long as two branches don't alter the same lines of a file, then you can merge those files seamlessly. The kind of, I'm going to do my example here. Let's go into the ingredients list. In fact, I'm going to make a new. No, I don't need to make a new branch. We'll stay on the roasted branch. So we're in the roasted branch, and we'll open up ingredients.txt. Oops, I'm having trouble opening. There we go. And let's say that as we're playing around with our roasting experiments, we also play around with the amount of onion to add. And we decide, actually, we like the flavor of this onion. Let's crank it up to a half of a white onion. And I make that commit on the roasted branch, or I increase the amount of onion. So increased onion. Now then I change branches over to the main branch. And I'm working on this file. I'm working on this part of the project a while. And as I do it, I realize, you know, half a teaspoon of salt, it really wasn't enough. We really did want more salt. We just got scared from the 3 gallons incident earlier, but it's time to come back to that. And while working on the main branch, I realized that 1 teaspoon of salt is better than half. So say I save that. And you can see we doubled the amount of salt. Now, if I want to merge these two files, these two branches, this should be pretty straightforward to do because we've changed different lines on the two different branches. If I open up ingredients here, you can see that, you know, on the main branch, I've changed salt and I've changed jalapenos. Whereas on the roasted branch, we switch over to roasted and go back to ingredients. Oops, got to reopen it. Whereas on the roasted branch, I've only changed the amount of onion. Like all of these are on separate lines, so merging should go through pretty seamlessly. So to do this merge, I'm going to go to this branches tab. And you'll see down here at the bottom is the option to choose a branch to merge into roasted. Alternatively, if my current branch is the main branch, you know, I can choose a branch to merge into main. So I'm going to go ahead and do that now. I'm going to take this and I'm going to merge the roasted branch into the main branch. And let's see, there's one conflicted file when merging roasted into main. Yes, you might get a notification here. What have I done here? Oh, sorry, I changed the other ingredients. 1 second, pardon me. Branches can be a bit to keep track of. Let's redo this. I'm going to just copy this in to the roasted branch. And on the roasted branch, we'll say that I change the amount of jalapenos. So we did ingredients, more peppers. Okay, let's try that merge again. Sorry, everyone. Apparently I've done something here. I'm going to just quickly reset these two branches. I'm going to try this demo one more time. Okay, so right now it should be that the two ingredients are the same on both branches. But when I open up the ingredients on the roasted branch, I want to change it to 1 teaspoon of salt like we did before. I'm going to save it. And on the roasted branch, we're going to increase salt. Okay, and now we're going to merge. We're going to merge the roasted branch with its slightly more salt into main. We got something in the chat. Yes, there was a Steam icon. Okay, so when we do this, we'll get the little check mark saying you can merge one commit from roasted into main. Click the button, it goes. And so this says we merge the roasted branch into main. Now, if you remember on the roasted branch, we added a little more salt. So now that we're in the main branch, let's look at the ingredients. And we can see that on the main branch, it also has more salt. So that version history they've been squashed together on the main branch. If we look at the history, you can see that that increased salt step, which happened originally on the roasted branch, is now also in the version history of the main branch. So I think it would be good if everyone tries to do a merge on one of their branches, or yeah, on 2 of their branches. Again, I apologize for the demo breaking there quickly. And yeah, if you have any questions, please just ask. Give a green check when you're done. And yeah, ask any questions otherwise. Yeah, so Anthony asks what the error was caused by. And so what went on there is somewhere as I was editing the 2 files, I edited the same line in both different branches. I think it might have been the peppers line. I'm not sure. Let's say it was the jalapenos line. Then it would be like I changed, 2 jalapenos to 3 jalapenos on the main branch. And I changed 2 jalapenos to 4 jalapenos on the roasted branch. And when I tried to merge, GitHub said like, whoa, hey, you changed this line differently in both different branches. I don't know how to choose which one is right. And that's actually going to be the very next exercise we do, is trying to resolve that error. Let's see, how are people doing? Is anyone having any other like merge conflicts, or I don't know, maybe it doesn't seem like the version history is being carried across right, or anything like that? No? Okay. So here I just want to emphasize, after you make a merge, you can push that merge commit. And it's thinking, and it's thinking. Okay, and it's done. We can go back to the repository online. And again, we can look at the different branches. We can see, okay, we can look at the ingredients list from on the main branch, and you can see that we doubled the amount of salt. We can also look on the roasted branch. And here you can see, this is what was, this doesn't have the double the amount of salt yet. And you might be like, wait a second, we merged into main, like why does main look good and why does roasted not? And the answer is we need to push the two different branches separately. So I had a bunch of changes on main, which I pushed, but I forgot to push the changes that I made to roasted. So that merged version history, that got pushed up when I pushed on main, but the changes that I've made to roasted so far have not. So I need to remember to push that separately. And this is much like how we had to publish main separately from when we published roasted. The two different branches are kept track of separately by GitHub. And so you need to treat each of them independently. So now that I've pushed here, let's go back to the repository. I'm going to navigate to the roasted branch. And now you can see in ingredients, there's the new updated amount of salt that was that was on the other branch. Okay. So yeah, moving on to kind of our final section here. We're going to talk about merge conflicts, and you've all just seen a live merge conflict happen. And this is very much just an issue of changing the same lines in two different branches. So kind of the example I've given here is like, here's that ingredients list. On the first branch, I'm using 3 jalapenos. On the second branch, I'm using 4 jalapenos. That would cause a merge conflict because GitHub doesn't know how to choose one branch over another. The branches aren't ranked, and so there's no way to say that one is superior. So how do we resolve that? Let's go ahead and make a merge conflict so we can kind of see what the interface looks like when that happens. So I'm going to do garlic cloves instead of jalapenos. So I just changed that to 3 garlic cloves, and I'm on the roasted branch. I'm going to commit that. And then, I'm going to go back to the main branch. Okay, I'm in the main branch. I go to the repository. I open up the ingredients. I'm going to change it to 4 garlic cloves. And I'm going to commit that. Increased garlic to 4. Okay. Now, when I try to merge, we're going to see that error that I saw before, where it says, hey, there's going to be a conflicted file when merging roasted into main. Let's say I'm like, whatever, I'm going to go ahead with this. I can click the merge button, and I'm going to come up with this merge conflict panel. And what this is showing me is that there's a file here, ingredients.txt, that has a merge conflict, and it doesn't know how to choose which line to pick from. So we could go into the files manually. I could go back and open up ingredients and be like, oh, that's right, I changed it to 4 garlic cloves in the other one, and I could edit the line manually. Alternatively, you might know which branch has the correct version. Like maybe you remember like, oh yeah, I did that bug fix on the main branch and I forgot to do it on the roasted branch. So the main branch is right. What you can do then is there's this little drop-down arrow, and you have the choice to choose which branch to use. So I could use the modified file from main, or I could use the modified file from roasted. Let's say let's say I go with main. That's me choosing and telling GitHub like, okay, the main branch is the more accurate one. You should value that one more. I'll take that. And now I can commit the merge. And that's what I did earlier when that issue came up. So now we can go and look at the main branch. We can look at the ingredients list. We see that it merged correctly, and there's the updated amount of garlic cloves. Yeah, so we've got about 15 minutes left. I would say if people want to go ahead and try to make a merge conflict, and then try to solve it, that'd be great. Let me know if you have any questions. And I think there is a survey that I saw the helpers, a feedback form passing around. So we could maybe put that in the chat again. And as people finish up with merge conflicts, we'd really appreciate if we could get any of that feedback. Let's see who had that form. But yeah, for now, let's go ahead and try out the merge conflicts. Mary's dropped the feedback form again in the chat. When you have finished with that, that's the end of the workshop pretty much. You are free to go. Or if you have any questions about anything we've done here, you can stick around till 12 to talk about. No, there's a lunch break after this. We can stick around to talk about them for a while. Or if you'd like, if you have any questions about other parts of maybe the GitHub website or parts of using GitHub Desktop, feel free to ask them also. Anthony asks, is there a way to see where and what the conflict is? And so you can kind of get an initial sense of what file it is in by when like create another merge conflict here. But if you'll recall on that merge conflict screen, it said like ingredients.txt, and then I had the option to choose which branch to like fix it with. That won't tell you which line it is in, but it will give you which file it's in. Some text editors like Atom have some packages where you can open up the merge conflict and it'll show the files like side by side, or it'll show you the specific line and like the two options of the line that you have. And then, yeah, you can open it in an external program and do it that way. But GitHub Desktop itself, not so much. Alma asks, can you only merge with the main branch, or can you also merge between two side branches? And you can merge any two branches at all. You can even, we didn't talk about this, but you can delete branches, and your project doesn't even have to have a main branch if you don't want one. So yeah, you can merge any branches. You have to re-download the repo to your local drive if there's a collaborator who worked on it last. Sort of. If you look at GitHub Desktop, you have the rightmost tab, which is the tab about talking to the remote repository. You don't need to re-download the entire thing, but there is a term called a fetch, which is kind of updating your local copy based on the remote copy. So if you see that fetch term up there, that often will mean somebody else made updates and maybe you want to update them as well. And fetching will often happen automatically when you make a push.
I think I'm gonna stop the recording now.
Okay.